Good evening, students. Am I audible? Good evening, students. Am I audible? The screen is visible or not?
Yes, ma'am.
Okay. I think after the mid exam, our class starts today. How was the mid exam? Question paper is easy or the screen is visible?
Yes, ma'am.
Yes, ma'am.
Okay. Our next topic is Unit 4, Exhibition Handling and Templates. In this unit, we are going to discuss the following topics. We have the topics like exhibition handling, user-defined exhibition. It means in exhibition handling in C++, we have two types of exhibitions, implicit exhibitions and explicit exhibition. We already discussed inline function in implicit functions and explicit function. The same way constructors, user-defined constructors and default constructors. The same way in exhibition handling also we have two types of exhibition, implicit and explicit. Implicit will be taken care by the compiler, C++ compiler, and user-defined exhibition. If you feel there is a chance of happening an exhibition, in that case, the programmer has to write his own exhibition handling routine. So that we will discuss what is exhibition, what is the condition, and when we can expect the exhibition, and if an exhibition happens, how to handle the unexpected occurrence of the constraints. Then the next topic is function templates. So that is also one of the object-oriented concept. So when we were discussing about the object-oriented concepts like classes, objects, inheritance, polymorphism, encapsulation, data hiding, then inline functions, virtual functions, front functions, operator overloading, function overloading, virtual functions. The same way, exhibition handling also one of the object-oriented concept, and the function templates is also one of the object-oriented concept. So that concept is not available in structured programming or in the normal procedure-oriented programming languages like C, Fortran, COBOL. So within the templates, we have function templates and class templates. So in the front functions, we saw two types of front functions now. Front class and front functions. The same way we have templates, two types of templates, function templates and class templates. Then within templates, how we can create the inheritance. Then we have the next topic called STL, standard template library. Then container classes, algorithms, how to what are the different types of container algorithms based on standard template libraries. Then the next concept, iterator, vector, list, stack, and map. So they are all the standard templates available in STL, standard template library of our C++ compiler. In C++ compiler, we have standard template libraries. Those libraries we are often representing using hash define or in the include directories, uh, stdlib directories. So if you install the C++ compiler, Turbo, C, Borland, C, or GCC compiler, you can see the header files. Bin library will be there, include library will be there, examples, and other mathematical libraries and string-based libraries, graphical libraries, built-in functions will be there. So those things will come under standard template libraries, or the user-defined programs can also be converted as standard template libraries. So within that, we will discuss what is iterator, vector, list, stack, and map. You know very well, vector means data with direction and value. Scalar plus vector. List means it is a subset. In arrays, we will group the similar type of data elements. In list, we can have collection of data elements. Stack, you know very well. First in, last out. Last in, first out. Map is an data type where we can locate any place in the world based on its latitude, longitude, and latitude. So these are all the topics we are going to discuss. Unit 4. Our first topic is called C++ exceptions. What do you mean by exception? Any idea? The exception is a standard keyword we often use in our real life scenario. We used to say some people are exceptional people, or they are the exceptional conditions. Can you give some example for real-time context where we are using the keyword exception? Almost all the keywords what we are using in C++ is the typical English keywords. What do you mean by exception? Any idea in general, in real life context? Mohit, give me an example. Mohit Raghuvanshi. What do you mean by exception? What are the other related keywords?
Sorry, ma'am, I don't know.
Any other person? Kavya Singh. What do you mean by exception? What are the exceptional conditions in general? Say, for example, you are going to write the mid exam. So in mid exam, they will check your ID card. So without ID card, you will not be allowed to write the exam. So but unfortunately, you forget to take your ID card. So that is an unexpected condition. In that case, how you will handle the situation? Vanshika, any idea? Something unexpected situation happens. In that case, how we can manage? What are the alternative things? How we will come out from the unexpected condition? So here exception means that it is an unexpected condition, or while executing your program, some unexpected things happens due to logical error or syntactic error or semantic error, or during runtime due to some unexpected looping. It goes in or some the delimiter condition is not reached. So in that case, if an unexpected error happens during your execution while executing any program, so if you feel, say for example, in general, we will say, give the example as divide by 0. So you are trying to find out division. In that case, A divided by B equal to the result. In that case, if the division by 0 happens, it is an unexpected error. Division by 0 is, what is the answer for division by 0? Any number divided by 0?
Infinite.
Yeah, infinite. So the, say in the for loop, if you are giving the delimiter condition as for I equal to 0, I less than n by a and I plus plus. So where you are giving the value for a and n. In that case, if a is given 0, if divide by 0 error occurs, it is an unexpected condition. It should go in infinite loop. So to handle the unexpected errors, or if you feel during the testing phase, if you feel there may be chances of getting some error, in that case, those kind of situations can be handled by using exceptions. Say for example, another example, if you go to the ATM and you are trying to withdraw the money, but the ATM machine is it's not having enough cash, or if it is exceeding the limit, or if something unexpected thing happened due to server error or network Wi-Fi error. So in that case, it has to give some answer to the end user. Say the person is trying to withdraw the money, but something unexpected server error happened. In that case, what kind of message we can see in the ATM machines? So what kind of message it will display in ATM? You are trying to withdraw the money in ATM, but due to some network error or server error, or no cash, or the denomination is not available. In that case, what kind of message we can expect? Or you are giving the password wrong more than 3 times, wrong password. What kind of messages or communication the system will display? So it will say system is under service, or system is not responding, or we cannot able to dispatch the money what you are so meet the nearby bank or contact the administrator. So like that, the system is displaying some answer, or it will say the system under service. That is a default message in general we will get. So those kind of situations will come under exception. When an unexpected error happens with the processing during runtime or during compilation time, the compiler has to display some, it has to throw some information to the end user so that they can understand something unexpected error happened. There is no syntactic error, there is no semantic error, but something is wrong in our coding, or due to some security issues, or through some network issue, something the system is cannot able to respond to the end user. So those kind of situations will come under exceptions or exception handling conditions. In general, in C++, when executing C++ code, different errors can occur. It may be due to syntax, or a syntax error, or a semantic error. Coding errors may be made by the programmer. So if there is a mistake in the coding, or if there is some error in the syntax of your coding line, executable code, errors due to wrong input or other unforeseeable things. So when an error occurs, C++ will normally stop and generate an error message. So in that case, if you already predicted this kind of error may happen, if it exceeds the limit or something, so the user, as a programmer, we can define our own exceptional routines, and we can through the messages to the end user so that the people can easily understand. The technical team for this is C++ will throw an exception or it will throw an error message based on the condition checked. In C++, we are using try and catch routines, or we will use the functions, try function and catch function. Exception handling in C++, it is consists of 3 keywords to handle the unexpected errors: try, throw, and catch. The try statement always allows you to define a block of code to be tested for errors while it is being executed. While executing the program, if you feel if the unexpected situation happens, this may cause an error message. The through keyword throws an exception when a problem is detected, which lets us create a custom error. And the catch statement allows you to define a block of code to be executed if an error occurs in the try block. The try and catch keywords are often used as a pair. Say, for example, say in every programming, we'll have analysis. It is called identifying the problem statement and writing the algorithmic steps for your given problem. And then we will go for the flow chart, that is called design. Then we will start writing our programming lines of code. So during analysis, design, and coding and implementation time, we need to always think about the quality. When you think about the quality, we will the testing will comes into picture. So if you think of as a programmer, we should always think about the quality, as well as we have to think what kind of errors if the condition is not met or if the constraint is not met. So if you feel there is a chance of getting an unexpected error in the lines of code, so to avoid or to handle those kind of errors during execution, we can go for this exception handling. So to handle the unexpected errors during execution, we can make use of the C++ exception handling routines. Here we are using the keywords try, catch. Say the syntax of the C++ exception handling is, we will use the keyword try. It means try this particular code. Say, for example, try the block of statement starts here, and through the exception, if this exception happens, and catch the error using the block statement. So we will use the syntax as try, open the block, and within that we'll write check for the exception, and if this exception happens, catch the exception through the catch block. Say, for example, we are testing the condition. If the age of a person is less than 18, and we know the condition. So if a person is above 18, then only they are eligible to vote. So if a person age is below 18, we have to tell to the end user, you are not eligible to vote. So how we can check this condition based on the age, what they are entering means. So we are using the try catch block. Say the try starts here, we are getting the value for age. Age is of integer type. Age is assigned a constant value 15. If age is greater than or equal to 18, then we will display the messages access granted. You are not old enough to vote. Else, I will throw the age. In catch block, what we will do? Catch int the age. See out access denied. You must be at least 18 years old to vote in the voting process. Then you have to display see out the ages. So here we use the try block to test some code. If the age variable is less than 18, we will throw an error message to handle the catch block. So in the catch block, we catch an error and do something about it. In the catch statement takes the parameter and it checks whether the age is met or not. Say in our example, we use int variable because we are throwing an exception in int type. Then the try block catches the age and it to output the value of age. If no error occurs, then if age is 20 instead of 15, it will display the message you are eligible to vote. Say here, you can also use the throw block to output and reference number like custom error number. Say, for example, we are fixing the age as 15 and we are in the try block, we are checking if age is greater than or equal to 18. access granted, you are old enough to vote. Otherwise, it will throw the error messages throw 505, where that 505 error message is catched by the catch block. So it will display the messages access denied. You must be at least 18 years old if your age is less than 18. So we can make use of so if you do not know the throw type used in the try block, in that case, you can use the three dots. So if the condition is not predefined inside the catch block, we will handle any type of exception. Say for example, try if age is equal to 15, if age is greater than or equal to 18, if the age is above 18, access granted, you can vote. Else it will throw the error message 505, where error 505 error message is mapped with the catch block, and it will display access denied. You must be at least 18 years old to vote in the process. So say for example, you are making an EVM electronic voting machine. In that case, you are checking the age of the person. Anyhow, if the age is below 15 means it will check the try block, and if the try block detects the age is less than 18, then it will throw the error message. Then the error message thrown by the try block will be catched by the catch block. Here the error number is mapped with the three dots. So here three dots means anything related to the throw block. So the 505 is matched with the throw block is matched with the catch block, and it will display for with respect to the error message 505. The corresponding definition is access denied because your age is below to vote. So what is exceptions means? Exceptions are events that can modify the flow or control through the problem. So while executing a program, if an due to input or due to execution error or due to parameterized error, that may cause an runtime error. So those kind of errors can be handled by using exception handling routines. They are automatically triggered on errors. So if an error occurs during the runtime, that will be triggered, that will be forwarded to the exceptional routines. So where we will use a try, exit, catch and recover from the raised by our Python exceptions, or we can go with try and catch block. So this exception handling is an error handling routine where error handling can be handled by using various built-in functions in Python, but in C++ we will use a try, catch. So any doubt so far in exception handling? Say how the exception handling in C++ is handled means, say we are using the three keywords, try, catch and throw. So the try block represents a block of code that can throw an exception during the execution, and catch block represents a block of code that get executed when error is thrown by the try block, and the throw block used to throw an exception. There is a special catch block that can it catches all type of errors. Say for example, in our textbook, the screen is visible. How the exceptions are handled? What are all the examples given in the textbook? So the exceptions are used to handle the errors generated by C++ classes. So the exceptions handling is a method of handling the errors. Exceptions are errors that occur at runtime. So that may happen during the runtime. They are caused by a wide variety of exceptional circumstances, such as running out of memory, not being able to open the file, or trying to initialize an object to an inappropriate value, or using an out of bound index or vector. So if your value is out of bound, that time also we may expect an exception. So why we need an exception means we need a new mechanism to handle the errors that may occur during runtime. So it was handled in the past. In C language, programs often signal an error by running a particular value. So in C, it will only display the error message. But in case of C++, the errors can be handled by the exception handling routines, and that may throw the corresponding error message. Say for example, null or zero to signal an error. Each time you can call one of those functions. Say if some function, so error routine value is identified. So how the exception is handled in C++ means, say for example, we have a class in C++, it's having collection of data and member functions. So while executing a function in the C++, an error occurs through the function. So in that case, it may be due to, if it is wrong, the function is called with wrong parameters, or the parameters are having some divide by zero error or something. In that case, it cannot able to produce the expected output. Then it may through the exception. It may call the exception handling routine. So the exception handling routine, he is having try catch and throw block. So here it will display the error. The error what happened during the execution will be mapped with the error handling routine, and it will display the error and the corresponding message, so that the end user can understand divide by zero error happened, or the age entered is not eligible to vote, or the ATM machine is out of cash, or the expected function cannot be executed due to invalid password, or there is a security issue, please contact the admin, like that. So the error whatever happened, the error number will be mapped with the exception handling routine, and that will display the corresponding error message. If the function is correct and the function will it is a good function call, it will perform the task and it will return the normal result. An unexpected error happened during the execution, the exception handling routine will be called to assist, and the error happened will be mapped with the exception handling routine, and it will display the user understandable message. Say for example, we are taking a simple exception example. So here we are taking a class called stack. It's having, so you know very well, stack means lost in, first out. The stack is having the size of the stack, and we are adding the values into the stack through the top pointer. And we have our class name is stack, and we have a function called range, and the constructor function. The stack is initialized with the -1 value. The stack index starts from 0, and we have the functions called push and pop. Using push function, we are adding the values into the stack. So while adding the values, the top pointer will be incremented, and the length of the top pointer will be plus top. The value will be added in the first index, 0th index, and the size of the stack will be reduced by max -1. Max is the size of the stack. Once you add the first one value, the size of the stack will be reduced, and the stack can occupy the values and up to the size of the stack. And using pop function, we can delete the elements from the stack. So if you perform the pop operation, it will check whether the top is less than 0. If the top is less than 0, there is no values in the stack. If top is greater than 0, it means there are some values in the stack. Then it will top minus, the top pointer will be minus, and the first last element will be popped out from the stack. So in the main program, we are calling initializing an object called, our class is class stack S1. Through the object S1, we are calling the function S1 dot push of 11. So the value 11 is pushed into the stack. S1 through the object S1 push of 22, push of 33, 44. So the values 11, 22, 33, 44 is pushed into the stack. So the stack is having the following values 44, 33, 22, and 11. And through the pop function, so using push, we are adding the elements into the stack. Through the pop, we are deleting the elements from the stack. So if you call S1 dot pop, the last element added 44 will be popped out. Then again, if you call 33 will be popped out, 22 will be popped out. So during this push and pop operation, if you feel error may happen means, so in that case, what kind of errors will happen means stack underflow or stack overflow may happen. If you are trying to add elements into the stack up more than the size of the stack, stack overflow will happen. The same way, if you are trying to delete the elements from the stack below -1, then stack underflow will happen. So we are writing the try block. So these operations will be performed. During this operation, if an error happens, catch the stack range and display the exception stack full or stack is empty. And arrive here. So during this push and pop operation, if you are trying to, so here we pushed 4 elements and we popped 4 elements. After this, if you try to perform pop, then the stack underflow, stack is empty and we cannot able to perform the task. So any doubt? What is exception and how we are handling the exception handling? So during the exception handling, what are the sequence of events will happen means, say the code is executed normally outside the try block, control enters the try block, and a statement in the try block ensures an error in the member function. So if an error happens in the member function, the member function throws an exception and control transfers to the exception handler following the try block. So that is the order of exceptions during exception or during an error condition. In that way, the exception handling is managed. So any doubt so far? The meeting will end in another 5 minutes. You have to join back. Any doubt what is exception handling? How we are handling the exception conditions using try catch and try catch block? Okay, the meeting will end in another 5 minutes. All of you join back.